Okay, so what we're doing now is we're looking at what are the odds for fourth place, fourth prize. And what is fourth prize? Fourth prize is matching four of the six numbers correctly. The bonus number is irrelevant. So we would, to find that odds, we would just find the number of total different ways that fourth prize can be won and divide that by the total number of ways that the game can be played, the total possible number of outcomes within the game. So to find the different ways that 4 out of 6 can be selected, first we would find the number of different ways 4 numbers can be selected from 6 numbers, and then we would multiply that the number of different ways the 2 numbers can be wrong, finding out all the different ways that you could win a fourth prize. And the first thing you would do is you would find out the number of different ways that fourth prize being four numbers match the 6 numbers that the state picked. So how many different ways can 4 numbers be selected from 6 numbers? And you would write that as a binomial coefficient. It's a combination because order doesn't matter. If order mattered, it would be a permutation, but it's a combination. And so it's 6 factorial. On the upper index you have 6, lower index you have 4. So you're selecting 4 from a pool of 6, any 4 from a pool of 6. So the numerator is 6 factorial, denominator is 4 factorial times 6 minus 4 factorial. So then that equals 6 factorial divided by 4 factorial times 2 factorial. The 4 factorial on the denominator is going to cancel out all the numbers within the 6 factorial below for the numbers 4 and below. So on the numerator, you just have 6 times 5 left over times 2 because the 4 factorial is canceled out, and then you're left with the 2 factorial, which is just 2 times 1. So you've got then 6 times 5 divided by 2, which equals 30 over 2, which equals 15. And so 15 being the number of different ways you can select 4 items, 4 numbers from a pool of 6 numbers where order doesn't matter. So how many different ways can those 2 numbers that were wrong, well, how many different ways can they be wrong? Write another binomial coefficient of 53 over 2. So again, this is 53 factorial divided by 2 factorial multiplied by 53 minus 2 factorial. And then you just follow all the exact same thing. What you eventually have is just 53 times 52 over 2, because the 51 factorial is going to cancel out the bottom half. Well, mostly, not just the bottom half, but every number of 51 and below within the 53 factorial. So then it's 53 times 52 is 2,756 divided by 2, because you got the 2 factorial still on the bottom. And the number is 1,378, and that represents the total number of different ways that the 2 numbers that didn't match up could be wrong. What are all the different possibilities? And this is regardless of whatever all these numbers, the 15 and the 1378. These numbers are all regardless of whatever 6 numbers could be picked. It's just the parameters are. You're selecting 4. You got 4 out of the 6 numbers correctly. So how many different ways can that be done? And then from the previous video, we figured out that there's a little over 45 million ways to play the game entirely. That's how many different ways can you possibly pick? How many possible different ways can you pick 6 numbers out of 59 numbers? And that number is 45 million. So the number of different ways that you can possible ways you can win fourth prize is a little over 20,000, because you're times 15 times 1378. You're multiplying the number of different ways you can pick 4 out of 6 numbers with the number of different ways that those two numbers that didn't match up could be incorrect. And so then you're left with this decimal here, and you multiply that. If you want to express the odds in percentage, you would just multiply this decimal by 100 to get the percentage, and you've got 46 thousandths of a percent chance of winning fourth prize per game. You're allowed 2 games per ticket, so that means you've got 92 thousandths of a percent of winning fourth prize per ticket. Now, what if you want to express it in how many will 1 in whatever it is? What are the odds for that? How do you express the odds that way? And you would just take the reciprocal of this number here, 1 divided by that decimal number there, and you get the number 2,180. So then you've got a 1 in 2,180 chance of winning fourth prize per game. You're allowed 2 games per ticket, so that would be 1 in 1,090 chance of winning fourth place per ticket. So 6.25%, according to the New York State Lottery website, 6.25% of total prize money is allocated to fourth prize. Now, remember, it was announced that first prize is $3.3 million, and first prize accounts for 75% of the prize money. So if you take 3.3 million, divide that by 0.75, you get 4.4 million, which is how we determined what the total prize money was. So 6.25% of that, 4.4 million times 0.0625 is $275,000, which is going to be allocated to fourth prize. Now, we determined the odds of winning fourth prize is 1 in 1,090 per $1 ticket. So, since we determined that the total prize money was 4.4 million, and it's advertised that 40% of ticket sales account for the prize money, if we take 4.4 million divided by 0.4, we get 11 million, that means there was $11 million in sales. So you can expect then for every $1,092 spent, someone's going to win fourth prize, statistically speaking. And so if you take 11 million divided by 1,090, you get 1,092. And so that means that there's roughly for this drawing, it can be expected that there's going to be 1,092 winners of fourth prize. They're going to have to split up the 275,000 allocated to fourth prize. And so 275,000 divided by 1,092 is $27.25, which is what someone should expect to receive when they win fourth prize.